Right. This lesson is very important, and we'll be looking at I'll call it our lesson 2. We're going to derive the formulas so that we can be able to find the length of an arc, then the area of a sector, the area of a segment, and also the area bounded by an arc, radius, and a right angle triangle. This is also very important, so please take your time as you watch this video. I also advise that you can be able to repeat until you really understand the question. So the first important thing is we'll be deriving I'll be just giving you the formula for finding the length of an arc. So here the length of an arc is the one that we have called S, so which means the one that I'm trying to trace here, that is the length of the arc that I'm looking for, which I will call S. So basically the formula for S, the length of an arc, is given by S is equals to R multiplied by our angle theta. So this is our angle theta, and you must always know that our theta must be in radians. So that's how you find the area, so the length of an arc. Now next we'll be now looking at the area of a sector. By saying the area of a sector, we'll be looking at this area here, this area that I'm shading. This is what I'm concerned with now here, and remember, as usual, this angle again will be given by theta, so which means this area A, it will be given by is given by half R squared multiplied by theta. That is the area of the shaded part here, which is the sector of a circle. Now, importantly, let's now look at the area of a segment. Right. If you are given that, and again our radius is R, angle here is theta, then the area of a segment, this is the area that I'm shading here, and that is the area of the segment. So we must also be able to find the area of that segment, which is the shaded area here. So as we do that, which means which means here, as we find the shaded area, which is our segment, I'm sure you can see that the segment is made up of two things. Firstly, it is the area of the sector. Can you see the sector here as the sector OACB? That is the sector of the circle. So which means the area of the segment, it will be given by area of sector, minus area of the triangle. I'm sure you can see triangle OAB. So which means here, and we know that the formula for the area of the sector is given by a half R squared theta minus, this is a triangle, and we know this angle here is theta, and this side is the radius R, and there is R, and by using the area rule, we know that the area, it will be equals to half of the side. By using the area rule, this side is R multiplied by this side again, it's R multiplied by the sine of our angle, which is sine theta. So which means now this is equals to half R squared theta minus half R squared sine theta. That becomes the area of the sector. Simplifying this, we can see to it that half R squared is a common factor, which means I'll be left with theta minus sine theta. So this area is, this formula is also very important. So this is the area of the segment of a circle. Now, also importantly, I want us to look now at this triangle, which I will just call to as the area. Find the shaded area. This is very important. As lifelong learners for mathematics, we must be able to understand this. It is found by 1. So we just want to find the shaded area, which means here for us to be able to find the shaded area, we are going to say we are going to say this area is going to be equals to 1. We are going to find the area of the sector. That is to say the area of the whole sector of everything here. And remember, our radius is still r, which means the length OA is r, and the length of OB again is r. And this angle here still is angle theta. And again, theta must be in radians. So which now means here we are saying this the shaded area that we saw, which bounded by CACB, this shaded area is given by, you say, the area of a sector, area of sector minus area of the right angle triangle. Right angle triangle. I'm sure you can understand that. So that's how you find the area of this sector. And let's now, the most important thing is, let's now find we know that the area of the sector is given by what? The formula, we already have it. 1, we are saying area of sector is given by half r squared theta, where my theta is in radians. And now number 2, which now means we're gonna find now the area of the triangle, And can you see this is a right angle triangle, which means it has a 90 degrees. That is 90 degrees here. I'm sure you can see the 90 degrees. Therefore, we must just use the area is given by a half base times height. I'll call my base OC and I'll label it the side OC, I'll call it X, and the side CA, I'll call this side Y. So which means it will be half of X times Y. But now we are most interested in finding what's Y and what's X. So look here now, for us to find X and Y, we are saying it becomes, can you see it's a right angle triangle? We can now use the sine ratio to say, for us to find the angle here, for us to find, we can say actually sine theta is equals to y, which is opposite. So which means it will be y over our hypotenuse. Our hypotenuse in this case is r. And therefore, which actually means making y the subject of formula, by multiplying there by r, it means y equals to r sine theta. And now for finding x now here, we can also see to it that we can even now say our cos theta is equals to x over r, which now means in this case our x will be equals to r cos theta. So which now means the area of the triangle area of the triangle, which is a right angle triangle, it will be equals to half base, which is half of x multiplied by y, which in this case it will be now a half of what's our x. We are saying our x is our y. What's our y? Our y is r sine theta multiplied by r cos theta, which now means it becomes a half r squared sine theta cos theta. Therefore, the area of the shaded part now, in this case, it becomes, therefore the shaded area, now, it now becomes, we say the area of the segment minus the area of the right angle triangle, and we said the area of the not the segment, the area of the sector, which means it will be now equals to half r squared theta minus the area of the right angle triangle, which is a half r squared sine theta cos theta. Therefore, which in this case, now simplifying this, we are saying it now becomes equals to, factorizing half r squared, it now becomes theta minus sine theta cos theta. Thank you. So this is basically how we can find the how we can derive the formulas. I hope this video has been very helpful to you. Please may you also watch the next video, and also please don't forget to comment and also like, as well as subscribing to the channel. Thank you so much. May God bless you.